Okay, just wanted to give a little tutorial about 10 minutes on drawing triangles with trigonometry. So this is a basic setup we'll start from. When you click on the guides, obviously you should try the student guide layout first to make sure you feel good about it. So when the kids do it, you've already experienced what they're experiencing. This video that I'm posting will be here on the teacher guide, probably how you got here, and I've included this set of prompts. So we've played around with this for a long time to figure out how to best initiate this. And we started by just saying, okay, put this prompt in front of kids. It's your challenge to draw a 90, 120, 150 triangle starting in the bottom left corner, and we're just going to go like a counterclockwise, starting with this side length of 90. So we'll do 90, turn 90, then go up. And if you've never drawn on Scratch before, you'll have to, in the new Scratch 3.0, you'll have to actually add the pen package in. And then once you do, some of the things are a little different than they used to be. Like this one used to say clear, it's now erase all, but you want to start with this basic structure. This resetting code structure here is helpful for kids. And so we'll basically start and say, what most kids will do that solve it, and usually it's only a couple kids that can figure it out, and it was designed to kind of be that way, but so I start playing around, and it depends a little bit on their background, right? But again, so the prompt says do 90 in the bottom, so we draw 90 steps first, making sure they understand that those are pixels, and then they're going to turn up counterclockwise 90 off of that. So notice if I ran this now, I can either run it here or run it with a flag, and it does that first drawing. It won't say 90 like it does in some of the pictures. I just put that in there to help direct kids. And then now the spacebar will keep resetting it. And so then they'll get that pretty easily. They'll even get the 120 here easily. And so that's where, after that is where it starts to get a little tricky. Because now they'll say, well, I don't know how far, I don't know the angle to turn to get back here. Well, some of them will be smart. It's usually one or two things. They'll either use like a go back to 00 command, almost like a homing. So I'll tab over. So because we started at 00 with the clear, if I ran this now, it would go back to where we started and close the triangle. So I would validate that. You know, it's a good problem-solving strategy to do. And then what most of them actually in our classes did was they guess and check the angle. So they keep guessing and checking and playing with the angle, and it comes out that the angle is about 143, and then they'll travel that 150 back. So then if I move 150 as the last step, that would be a really strong strategy. You could even have a student come up and show that if you had one. But then talking about why this exterior angle, the character was moving straight up, so it's this exterior angle that the turn was made, so more approximately this acute angle inside the triangle that we actually wanted was 37 degrees. So that's where you'd start, and then from there, that we call the initial task, and then from there, if you would say, well, I'm sorry, I guess the prompt for that one isn't on here. You have to go down to the student guide. I might as well pull that up anyways. And then from the student guide, it will say, for task 1, we challenge you to turn an exact angle. Now, if you're doing like partner programming, it can be really helpful where the kids pull this up and actually see it, so they can see like the GIF move and everything. If you've done this standard inverse notation, Scratch just shorthands it for arctan with an atan. So teaching them, well, what if we wanted something more exact? Like if I had this more precise, if I zoomed in, would that actually be matching up correctly? And so in the operators, underneath this absolute value block is where all the trigonometry is stored. So you have regular, sine, cosine, tangent, and then you have the inverse functions. So if we did arctan, and this is where you could even draw it up on the board or have them draw it on paper and say, well, that angle that you turned, actually had a 3 to 4 ratio. So this is 90, this is 120. We got that from the 3, 4, 5 primitive. So then you could, it won't let you actually divide in here. You could just put 0.75, but if you wanted to show division, you have to pull in division block. So 3 divided by 4. And now understand, if you put this in here, then it will turn the acute angle, right? So I'm going to clear that, and I'm going to run it. Notice that it doesn't work because you're actually turning the interior angle, and it's the exterior angle that you want to turn. So that's why you have to have the 180 minus concept here. And now if we run. So we can just have a good conversation about how that exactness, and you can actually even pull it out and click on it, and it tells you that it's not even 134 or 143, it's 143.10, and it pulls this out, a lot of digits. So just the precision of that and the accuracy, you could have conversations about what types of things would want such accuracy in angle degrees, and you can have conversations about instruments in, naval ships or aircrafts, whatever it might be, but there would be a good conversation there to have with kids about precision. So that's that first initial task. Now if we slid that into drawing excuse me, sorry, this is just this will be about the same, just changing the sides. So once you do this together and talk about it, can they do it on their own in task 2? And all the solutions are always at the end of the teacher guide. So the one that you got access to is the teacher guide, so solutions are here. You could post for the kids or check yourself. So that second task, this is what it would look like with tangent. But then going into one where you're solving, where you have to solve side lengths, if you had this triangle, well, what if we used some actual variables? So this is the last piece I'll do for the video. So instead of just having this, I could be like, what if we wanted to have, in this triangle, you don't know how long this first side that you want to move is, so let's just call it x for now. And again, you could have them draw it out, and you'd see that that's a cosine, because this is an adjacent like this. So the cosine looking from 35 is adjacent over hypotenuse. And then solve for x. And they would see that x is equal to 100 times the cosine of 35. So I've already made these variables, but to make them, you just click Make a Variable. To have them show up in the screen, you just have to check them. So if I had x here, let's say I called that x, called this y. My variable, I wasn't using that one, sorry. So then I have to make one called angle A. I try to get in the habit of doing it the way a programmer would do it. So typically they do lowercase, and they do underscores to connect things, so they're all one word for variables. So if you've never done variables before, you would be advantageous to pulling these set blocks. And so I'm going to set all 3 of those right from the beginning. So I'll say x, y, and angle A. Now again, it's not necessarily a correct way to match them up in there, but I would say have them do it by hand first, and then they'll need a multiplication. So it's going to be like this length, this first length they're going to travel is 100 if they wrote it on paper, times the cosine. Sorry. So I change this to cosine, not cosine inverse, right, because we're doing length here, of 35 degrees is the way the picture was drawn. So that's going to be your actual x length. And then so for our first move here, we're not going to move a static or fixed value like 90. We're going to move x. So maybe I'll move this stuff, I'll disconnect it and just run this code. Let's do a space bar, just run that code, and you'll see that that first traveling path then is about 81.9. Okay, and then if you guessed, this height is just going to be the sine ratio. So when you solved it, if you solved it on paper, it just comes out to be the same thing. So notice how I right-clicked on that, and I can just click duplicate, and I'll just change this to sine. So 100, the sine of 35 is that height, And then, so for the second one here where I did my move, still turning the 90, right? Still turning this 90, moving the x, turning the 90, but now we're moving this y distance up. And then our last step is going to be to do the same turning, only instead of having a 3 to 4 ratio, we're just going to have an x to y ratio. So if that adjacent leg we called x, and the opposite leg we called y, now I can just piece those in as the arctangent ratio. And then our last drawing in is the hypotenuse of 100. So I would say, you know, what the prompt was is, oops, I'm sorry, I should have done it like set angle A to that stuff, and then I can move, turn angle A. Yeah. And I would challenge them for every unknown, make a variable so they have to store it into that variable and try to use the trigonometry and exactness. Even though this angle right here will come out to be, I guess I haven't ran this code yet. So even though this angle turns out to be, well, it's not, I guess, because of the ratio, but it is exactly 125. So there's that drawing, and they can always move the sprite at the end to see if it matched up correctly, and then, you know, move some of these around. If you don't like that this is showing the exterior angle, which I have the keys set up so they actually show the exterior, then you could just make it so, you know, you could set angle A still to this. This is what the interior angle is equal to, and then you could turn 180 minus that down here, if that makes sense. So now if I ran this, that does show up to be the acute interior angle. Okay, so hopefully that's helpful, and it was a good tutorial for you guys to start off with. Thanks for watching.